block of mass M hangs from a string wrapped around a cylinder that is free to turn around its center. That also has a mass of M. Find the angular acceleration of the cylinder. First we have to do like a lot of things. First we are given the mass of the cylinder and the block. Uh, but then every cylinder has a radius basically, unless it's an irregular cylinder. Uh, so there will be a radius, and that will be important later. But what you need to know right now is the block the block is not rotating. So no matter what we have to use Sir Isaac's second law, which is the force equals mass times acceleration, and that acceleration in this case is gravitational acceleration. I know it's probably blocked by the Fillmore watermark, but yeah. But then there's also going to be tension on the string created by the gravitational force of the block. And as you can see, the cylinder is basically a pulley, and it will rotate. So that means we would have to use Sir Isaac's second law, except we replace it with torque, which is basically the rotational force, I guess. That will equal moment of inertia times alpha. So first, we have to get the net force on the block. So the force on this block are gravitational force, which is labeled as m times g, and tension, which is the string on the block. So first, we will assume that the mass times gravitational acceleration is the positive direction. So, and since t is parallel but opposite, since tension is parallel but opposite of gravitational force, we just need to subtract it from the gravitation. We just need to subtract t from the gravitational force. Thus, mg minus t is the net force on the block. So we're looking for the net torque of the cylinder. So we have one equation which is tau equals I times alpha, and that is not enough even if we plug in moment of inertia for a cylinder. Um, so we have to use another equation for torque, which is r cross f, r being radius, f being force, and that will be the same as r times f sine phi, phi being the angle between the radius and a and the direction of force basically. So but then in this case we can assume it's perpendicular. So sine of 90 degrees or pi over 2 radians is 1, excuse me. So and now so it basically just cancels out. So we need to plug in something for f. So the only force that is directly acting upon the cylinder would be tension, and tension is going down, so tension has to be negative. So the net torque of the cylinder is r times t negative. Don't forget the negative. So now we can plug in I for the torque equation, which is inertia times angular acceleration. So the moment of inertia for a cylinder is mass times radius squared over 2. So we can plug that in for I, and so that just leaves us with mass times radius squared times angular acceleration over 2 will equal the other equation that we had earlier, which is negative r times t. So we set I times alpha, excuse me, equal to negative radius times tension. So we can cross out the r's, um, and there's only one r left on the left side. And now we have m times r alpha over 2 equals negative t. But we have something for equation t. We have something for negative t. So now we plug in the the force acting upon the block, and then so yeah, it'll just be mg negative mg equals negative t. So now it becomes mr alpha over 2 equals mass times gravitational force, but make it negative basically, and then now you cancel out the m's, and th- and then multiply both sides by 2 over r, and then you get 2g over r um equals alpha. So your answer for this question is probably different from what I got, but my answer for this question is 2 times g over r, and that's your angular acceleration. I don't know if it's in revolutions per minute or radians per second squared, something like that, but this is my answer. You guys probably got a different answer, but that's all I got. But anyways, thank you guys for watching. And if you're reviewing this, please drop a dislike. Do not drop a like, or I break your knees.